Hello everyone, and welcome to the second video in the AS Biology series. In this topic we'll be talking about mole and molar solutions. So what is a mole? Well, a mole is the unit that we use to measure the amount of a substance. And 1 mole can be defined as the same amount of particles as there are in 12 grams of carbon-12 atoms. And 1 mole is also equal to this number, 6.022 times 10 to the 23, which is also called Avogadro's number. So another way of saying this is 6.022 times 20 times 10 to the 23, which is 1 mole, is equal to 12 grams of carbon-12. So, as carbon-12 has an atomic mass of 12, hence why it's known as carbon-12, we can say that 6.22 times 10 to the 23, or Avogadro's number, is equal to 1 gram of each of this atomic mass number. So we can take any element from the periodic table. So I've chosen zinc here. The atomic mass number is at the bottom here, so 65.38. So could you tell me how many grams are in 1 mole of zinc? Well, that's easy, it's just the atomic mass number itself. So rounded down, 1 mole of zinc is equal to 65 grams. Or, another way of saying this is 65 grams of zinc has 6.022 times 10 to the 23 particles in it. So, how many grams are in 2 moles of zinc? So 2 moles is simply 65 times 2, which is 130 grams. The same principle can be applied to compounds. So here we have salt, or sodium chloride, NaCl, and we know the individual atomic mass numbers of both of the elements. So to 1 decimal place, sodium has an atomic mass number of 23, and chlorine has an atomic mass number of 35.5 grams. So 1 mole of sodium chloride is simply the atomic mass number of sodium, 23, plus the atomic mass number of chlorine, 35.5, which equals 58.5 grams. So we know 2 moles of sodium chloride is equal to 58.5 grams. So we know 2 moles of sodium chloride is equal to 58.5 grams times 2, which equals 117 grams. So what is the point in moles? Well, it allows us to translate between the atomic mass number and grams. To many people, this number alone, 65.38 atomic mass number, doesn't mean anything, but this conversion puts it into units that we readily use of grams. Now let's look at molar solutions, which is a solution that contains 1 mole of a solute, which is a dissolved substance, in each litre of solution. So look at the question below. How many grams do we need for a 500 milliliter solution containing 3 moles of sodium chloride? Well, in the previous example we already worked out what 1 mole was, which is 58.5 grams, and we want a solution containing 3 moles, which is 58.5 grams times 3, which is 175.5 grams. And going back to the definition, so a molar solution is a solution that contains 1 mole of subject per litre, and we only have 500 millilitres, not a litre. So we half our number that we get, so 75.5 grams times 0.5 is 87.8 grams. So to get a 3 mole solution of sodium chloride in 500 millilitres, we need 87.8 grams of sodium chloride. Okay, so very briefly what we've learnt. So we've learnt what moles Avogadro's number is and what molar solutions are. We've learnt how to convert moles to grams using the atomic mass number. And we've also looked at how we can calculate molar solutions. So that's it for this topic. Next up we're going to talk about carbohydrates, and specifically a single monomer unit of sugar known as a monosaccharide. So if you liked the video or found it helpful, please give a like down below and maybe subscribe for more content like this, and I'll see you next time.